Look at something called a complete bipartite graph on MN vertices. So these are going to be two different groupings. So this would be, let's say we have a left group and we have a right group. Those groups cannot connect with other members inside their own group. They can only connect with members outside of their group. So imagine you're doing a classroom activity, right? And you have a piece of paper that's been cut, and you have to find the person on the other side of the room that has the matching cut piece of paper. And you might go to several people on the other side of the room to see if they have the other half. But you're not going to talk to people who are on your team because they have the same side of the paper that you do. So it's not going to make a match for sure. Okay, so let's look at what this looks like. There's all kinds of definition here. Go ahead and read through that. But I think sometimes just getting to it kind of helps. So I'm going to draw those. First, I have K32 and K33. So K32 will be this one, and I'll do K33 over here. So this one, I'm going to draw two groups. Right? So imagine the left has the left side of the paper and the right has the right side of the paper, and we've got to get them to match. So I would have 3 vertexes on this first side, and I would have 2 vertexes on the other. Now these are going to be complete bipartite graphs. So you know what we have to do. Every single vertex is connected to every other vertex. The only challenge here is that you can't connect it with its own. So I'm going to take my line here and I'm going to connect it to this one. So I'm good. Then I'm going to connect this one over here. So now I have that first one connected to both on the other side. Then I'm going to take the middle one and I'm going to go ahead and connect that to both of them. And it's starting to look like shoelaces on shoes. Then I'm going to go ahead and connect this one, and then we'll connect this one. And that is a complete 3-2 bipartite graph. All right, we're going to do another one. This is a 3-3. I am not going to draw the groupings around it. I think you guys can go without the groupings. It was good for our visual, but we don't need it anymore. So a 3-3 is going to be exactly as it sounds. I have 3 on this side, and I have 3 on this side. And so with this, I'm going to connect this first one, and you can label each of these vertexes. So, if we want to call this V1, V2, V3, and call this W1, W2, W3, right? Just to kind of keep them separated. All right, let's take a look and connect this one with that one. And we're going to connect that one with it. Then we're going to connect this one, and this one, and this one. And then we're going to connect this one, and this one, and this one. So now we have a complete bipartite graph that is 3-3.